So you close your eyes, the room becomes quiet, your body relaxes, but your brain is just getting started. Every night you enter a world that feels impossible. You fly without wings. You meet people who disappeared years ago. You run from dangers that never existed. Then you wake up. Most of it vanishes within minutes. For thousands of years, people believed dreams came from gods. Others believed they were messages from the dead. Some thought dreams revealed the future. Today, scientists have a different answer. The truth is even stranger. Dreams are not random movies inside your head. They are the visible result of one of the most complicated processes the human brain performs. Every night, billions of neurons fire in carefully changing patterns. Chemicals rise, others disappear. Entire brain networks switch on while others fall silent. The experience feels magical. The biology is astonishing. Why would evolution spend so much energy creating dreams? The average person spends about 6 years of life dreaming. That is an enormous investment. Evolution rarely wastes energy. If dreams survived millions of years, they probably served a purpose. The question is not whether dreams matter. The question is why they matter. Scientists have searched for that answer for decades. Some believe dreams strengthen memories. Others believe dreams prepare us for danger. Still others think dreams help regulate emotions after difficult experiences. Surprisingly, each theory has convincing evidence. The story begins long before humans existed. More than 300 million years ago, early mammals evolved increasingly complex brains. Sleep itself became divided into different stages. One stage would eventually become known as REM sleep. REM stands for rapid eye movement. During REM sleep, your eyes move quickly beneath your eyelids. Your muscles become almost completely paralyzed, yet your brain becomes remarkably active. In some regions, activity nearly matches being awake. This discovery shocked scientists. Sleep was supposed to be quiet. Instead, one stage looked surprisingly alive. In 1953, researchers Eugene Aserinsky and Nathaniel Kleitman identified REM sleep while studying children. Whenever subjects entered REM sleep, they almost always reported vivid dreams after waking. The connection was undeniable. Dreaming and REM sleep were deeply linked. That discovery transformed sleep science forever. But it also created a mystery. If the brain is almost as active as when we are awake, why can't we simply wake up? The answer lies inside your brainstem. Tiny groups of neurons release chemicals that disconnect your muscles from your intentions. This temporary paralysis protects you. Without it, you might physically act out your dreams. Most nights the system works perfectly. You run inside the dream. Your real body never moves. Occasionally the system fails. Doctors call this REM sleep behavior disorder. People punch, kick, jump from beds. Some even perform surprisingly complex actions while asleep. These rare cases reveal something remarkable. The dream is not passive. The brain is generating an entire virtual world. Your senses are disconnected from reality, yet your mind accepts almost everything. A talking animal feels normal. Gravity suddenly disappears. Time changes direction. You rarely question any of it. Why? Because the logical regions near the front of the brain become less active during REM sleep. Meanwhile, emotional and visual regions become highly active. Logic fades. Emotion takes control. That explains why dreams often feel emotionally overwhelming. Fear becomes terrifying. Joy becomes unforgettable. Embarrassment becomes unbearable. The brain's experiencing emotions without the normal filters of waking life. Psychologist Rosalind Cartwright spent decades studying how dreams affect emotional recovery. Her research suggested dreaming may help people process painful experiences, not erase them, process them. Imagine carrying heavy boxes every day. Eventually your arms become exhausted. Emotions work in a similar way. Dreaming may reorganize emotional memories, making them easier to carry tomorrow. That idea gains support from modern brain imaging. During REM sleep, stress-related chemicals called norepinephrine drop dramatically. This creates a safer chemical environment for revisiting emotional memories. You experience the memory again, but with less biological panic. It is almost like emotional therapy occurring while you sleep. Could your strangest dreams actually be helping you heal? The answer is probably more complicated. Dreams appear to serve several purposes at once. Memory is one of them. Every day your brain absorbs an astonishing amount of information. Faces, names, sounds, conversations, tiny details you never consciously notice. Most of it cannot be stored forever. The brain must decide what stays and what disappears. That process continues while you sleep. Neuroscientist Matthew Walker describes sleep as one of the brain's greatest information processing systems. Experiences from the day are gradually transferred into long-term memory. Some become permanent. Others quietly fade away. Think of a crowded library. New books arrive every hour. Without librarians organizing the shelves, chaos would eventually take over. Your sleeping brain works like those librarians. Dreams may be one visible side effect of that enormous reorganization. Researchers have tested this idea in fascinating ways. People learned difficult tasks before sleeping. Others stayed awake for the same amount of time. Again and again, the sleepers performed better. Their brains had continued practicing after their eyes closed. Sometimes improvement appeared without any additional training. It almost looked like learning continued automatically. The brain was working overtime. Then came another mystery. People often dream about events that happened recently, but rarely exactly as they happened. Instead, different memories become mixed together. A childhood friend suddenly appears inside your current workplace. Your old school becomes an airport. A family member speaks with someone you've never met. Why combine unrelated memories? One explanation comes from neuroscientist Robert Stickgold. He suggests dreaming helps discover hidden connections between different experiences. Rather than replaying yesterday like a recording, the brain experiments with possibilities. It searches for patterns, it tests ideas, it creates unexpected combinations. Sometimes those combinations become creativity. History is filled with remarkable examples. Chemist August Kekule struggled for years to understand the structure of benzene. Then one night, he dreamed of a snake biting its own tail. The circular image inspired the ring-shaped structure that transformed organic chemistry. Whether every detail of the story is perfectly accurate remains debated. Its influence on scientific history does not. Inventor Elias Howe reportedly dreamed about warriors carrying spears with holes near their tips. After waking, he realized sewing machine needles should place the eye near the point instead of the base. His invention changed manufacturing forever. Even musicians have credited dreams. Melodies, lyrics, entire compositions. Ideas sometimes arrive from sleeping minds. Could dreams actually make us smarter? Not exactly. Dreams do not magically create knowledge. Instead, they may rearrange existing knowledge into combinations we never considered while awake. Creativity often begins with unexpected connections. Dreams specialize in unexpected connections. But dreaming is not always pleasant. Nightmares can feel horrifying. Your heart races. Your breathing speeds up. You desperately try to escape. Sometimes you wake before the danger reaches you. Sometimes you don't. Why would evolution preserve terrifying dreams? Psychiatrist Antti Revonsu proposed the threat simulation theory. According to this idea, dreams allow the brain to rehearse dangerous situations safely. Imagine practicing for an emergency before it happens. Your body remains protected in bed. Your brain gains experience. Primitive humans constantly face predators, hostile groups, natural disasters, environmental dangers. Those who mentally rehearse threats, even unconsciously, may have reacted faster when real danger appeared. Dreams became survival practice. Modern nightmares still reflect ancient fears. Being chased, falling, getting trapped, losing loved ones. These themes appear across cultures worldwide. Different languages, different religions, different continents. Remarkably similar dreams. The fears changed less than civilization did. Children experience nightmares more frequently than adults. Their brains are rapidly learning about the world. Everything is new. Everything feels uncertain. Dreams may help organize those overwhelming experiences. Even adults dream more intensely after emotional events. Examinations, breakups, moving to a new city, major life changes. Stress seems to influence both dream frequency and dream intensity. Have you ever noticed that your strangest dreams often arrive during your most stressful weeks? That pattern is no coincidence. Scientists continue discovering new connections between sleep, emotion, and mental health. The sleeping brain may be doing far more work than we ever imagined. There's another mystery. Some people become aware that they are dreaming. The dream continues, but suddenly they know it is not real. This is called lucid dreaming. For centuries, many people believed lucid dreaming was impossible. Then science caught up. In the 1970s and 1980s, psychophysiologist Stephen LaBerge demonstrated that lucid dreamers could communicate with researchers. Before falling asleep, participants agreed to move their eyes in a specific pattern once they realized they were dreaming. During REM sleep, those exact eye movements appeared on laboratory recordings. It was extraordinary. A person was asleep, dreaming, and consciously sending signals to the outside world. Lucid dreaming showed that consciousness is not simply on or off. It exists on a spectrum. Your brain can create an entire universe while another part quietly watches it happen. That realization changed how scientists think about awareness itself. But not everyone remembers their dreams. In fact, most dreams disappear within minutes of waking. Why? Because the brain treats dreaming differently from waking life. During REM sleep, the hippocampus, which helps form lasting memories, is less effective than when you are awake. The experience feels unforgettable while it is happening. Then it slips away, like writing on water. Researchers estimate that people have thousands of dreams throughout their lives, yet we remember only a tiny fraction. Entire adventures, entire conversations, entire worlds, gone forever before breakfast. Perhaps the strangest question is this: why do dreams feel so real? The answer lies in prediction. Your brain is always predicting reality. Right now, it combines information from your eyes, ears, skin, and every other sense. During dreaming, those external signals almost disappear. Instead, the brain generates its own reality from the inside. To itself, the dream is reality. There is no difference. That is why impossible events seem completely normal. The brain trusts the world it created. Only after waking do we recognize how strange it truly was. Artificial intelligence researchers have become interested in dreams for a similar reason. Some computer systems improve by replaying experiences and testing different possibilities. The human brain appears to do something surprisingly similar. Not perfectly, but enough to raise fascinating questions. Could dreaming be one of nature's oldest learning algorithms? No one knows for certain. Scientists still debate exactly why dreams exist. There may never be a single explanation. Dreams likely evolve because they solve many problems at once: strengthening memories, processing emotions, exploring creativity, preparing for danger, maintaining healthy brain function. Each night your brain quietly performs billions of calculations without asking permission. You never hear them. You never see them. You only experience the story they create. Then morning arrives. You open your eyes. Most of the story disappears, but its effects remain. A memory feels stronger. An emotion feels lighter. An idea suddenly makes sense. A difficult decision becomes clearer. You think you simply slept. Your brain accomplished far more. Tonight, when you close your eyes, another invisible journey will begin. You may visit places that never existed, meet people you have never known, solve problems without realizing it, or confront fears that have followed humanity for thousands of years. You will wake believing it was just a dream. Yet those dreams may have quietly shaped who you become tomorrow. The greatest mystery is not that we dream. The greatest mystery is that evolution chose to spend nearly a third of our lives asleep, because the sleeping mind may be just as important as the waking one. The next time you wake from a dream you cannot remember, consider this. Perhaps forgetting the story was never the point. Perhaps changing you was.